John Cook with GM. I was just curious about, as you deployed from site to site, how did you manage the skill set between the people that can develop the analytics and deploy it effectively for those operators? How did you skill the site, or how did you take that knowledge from site to site?
I think both our companies, both Kimberly-Clark as the customer and Schneider Electric, are learning how to do that as we now have accelerated this rollout plan. I would say the first piece of success we learned from lean transformation. So it's necessary to take some resources from a pilot site that's already implemented and immerse them in a site that's about to go. So very specifically, we've taken the lead project engineer and a couple of particularly the IT resources from the previous facility in LAO. We've taken them to the next facility in Colombia from El Salvador, and we have them consulting there. Another idea is that you've got to have critical subject matter expertise on each deployment team. So if you've got multiple deployment teams, you've got to have a population of common experienced resources so that you roll it out in a standard manner. I will tell you, early in this rollout, that's been a struggle that both of our companies have talked about, to figure out how to man simultaneous deployment of this, particularly when the mindset and capability work is very specific to the culture of that given mill. One thing we're considering is asking the next mill in line that's going to implement to go ahead in advance and send their resources from their facility backward to the mill that's about to implement now, so that you actually have participants from 3 mills: the last one that's done it, the one that's currently doing it, and the one that's about to do it, and then gain that sharing of resources and standards across that. And I think we'll start to see common elements or common challenges that we can get through faster and maybe accelerate the implementation that way. At this point, I'm still begging resources to do that. So that's a plan. That's not reality yet.
I think this is a valid question for Manuel as well, because you rolled out your application through 3 different deployment sites throughout the world, being one in Shanghai, one in Mexico, and I've forgotten what the third one.
The other one's in France. Right?
The other one's in France. So we have a huge cultural difference. And so maybe you could speak to that deployment experience as well, and what maybe you saw maybe in cultural differences or capabilities differences and those
Sure.
things.
I think in our side, and we believe, we all speak English here, but the rest of the world sometimes it's not, right? Even highly technical persons in your operation, right? So I think a mistake we've done in the past, is that we roll out this type of solutions, assuming that everybody's going to speak English and go through a menu, right? So that's something we were able to put in this application. I'll let Josh, add more information on that. Include the person since the get-go, right? Put them in the analysis requirements. Make sure that that the expectations and the things they want to have solved in the current system they're working with are not inherent in the new application or the new software rolling out. I think that's been a key for success to us on that.
What I'll add to that is also going along the lines of what Stewart said in terms of involving people along the lines. And so as things were being deployed in Mexicali, there was key people that are going to be working with it at the other sites. And the communication, as it was being rolled out, here are the issues we're coming across, here's how we're solving them. And so they were aware of what was coming and what we ran into. And so it wasn't like we get to the new site and they were blindsided, something new, they never really saw what was coming. So by involving them and then bringing people back to a facility in Mexicali and doing some testing there, letting them see what is different, why it's different, and what the advantages are, and then take that back, those thoughts and ideas, to their facility before the rollout happens there. That was a huge win and something that has worked very, very well to involve people across during the implementation. And the key was communication. It really was. And to keep people informed of the whats and the whys and the benefits throughout the entire process.
Okay. Go ahead, Kevin.
Yeah. One of the things. Good. One of the things we also did on this is up front we recognized this and we looked at this as a global deployment. So putting these envelopes around machines, processes, That was done with it being global in mind and multi-phased rollouts in different countries. So we recognized that. We worked on that at the very beginning. We created an assessment tool so that wherever you go in the world, you can go out to assess what their structure is under our lean visual system, the meters that are feeding it, the connectivity of the plant, things like that, so that we could see what infrastructure had to be in place before we start the lean deployment, so that we could time this through multiple sites and multiple systems, language, all those things. So all that's in place as we go forward to make sure that it's both done to lower the cost on all companies involved to be able to deploy this in multiple places, multiple regions, and we get specific people involved where it's needed, whether it's the metering or the connectivity. So we address that right up front.
Oh, we have another question.
Thanks. Jim Bowsing from Owens Corning. Probably a question for both of you, but maybe we'll start with Stewart. I'm interested in how you set the initial targets for your dashboards. Is that done through baselining, best practices? And then maybe depending on your answer, I may have a follow-up for you on it.
I'm looking over at a couple of our partners because that was a lunch discussion. I think you have to differentiate between the term benchmark and target. In our glossary, a benchmark is a best-in-class performance for energy per unit across a given class of assets. So back to your question from Miller Coors, where do you set that level, right? It's important to have a few benchmarks, but you don't want to have 30,000 benchmarks or they're meaningless, right? So first we chose the classes of assets and we looked for the best-in-class performance, and we have a handful, I'm going to say a dozen standards for energy per unit at that machine level, okay? And that we call benchmarks. Now, setting a lean target is a completely different animal and has to be owned by the facility. They need to be able to see what their assets class is and what the benchmark level of performance is for best in class for that, but they have to set a continuously improving target, and that target has to be very much instantaneous. If you want to have a monthly result that averages a certain consumption, you have to have an instantaneous target that's much more aggressive than that in order to average that, because you've got these abnormal conditions that are going to take away from your average. So you have to give them the ability to set a continuously improving target, and we're very much in the early stages. The early mills that have done it have said we've got to be meeting that instantaneous target 2/3 of the time before we'll consider improving or raising the bar, ratcheting up that internal target, but they very much own setting their own internal target. They're measured against their deviation from the benchmark. So we base their overconsumption number globally and reflect it to their business unit leaders based on how much they overconsume against the benchmark amount of energy for that process. And we've been doing that for years. We just haven't been able to give a tool that allows you to do anything about it behaviorally and how you use the energy till we've come up with this lean energy approach. So I hope that helps.
Yeah, no, that was really good. I was curious how you were integrating it in your continuous improvement process. But second, maybe then there's a follow-up. Have you guys looked at end-to-end optimization of energy consumption across the entire asset, meaning that you may forego energy on one particular asset in order to meet an overall objective that gives you a much better footprint overall across the whole facility?
Not at an asset level. What we do instead, and my team's responsible for supply side procurement management of energy purchased as well as demand side conservation reduction. So what we'll do is we'll analyze the market trends for the price mix of certain fuels that could be used, and we'll attempt, for instance, if we have what we call a spark ratio of 4, meaning electricity is 4 times the cost of natural gas, and we have reliable natural gas, we'll consider a cogeneration solution where we'll deploy a turbine, turbo, a gas turbine. See, I'm already using your stuff. And we'll generate electricity for ourselves, and use the waste heat from the stack to dry our product with and get the benefit there. So you're foregoing the use of natural gas and improve your carbon footprint and getting the gains in terms of improvement in use there. So we've looked at that from a holistic standpoint, but really, unless you're talking about shedding load for peak demand management, we really haven't looked at offing other parts of the process. Now, if we're on interruptible energy, which we are interruptible power contracts, which we are now using as a management lever in our Hoshians, in our strategies for managing energy cost, we'll get a price break in many parts of the world for interruptible power, many parts of the United States included. And we take a look at the grid demand, how likely is it that we're going to be called for interruption versus the business loss and the critical nature of those product order timing. So if the more and more we go to just in time, the less inventory working capital you have in the warehouses, the less you can do interruptible power without a problem. But by analyzing the likelihood of a power interruption, many cases there's very little risk that you're actually going to be interrupted. And even if you are, you can look in a mill and say, if we are interrupted, we'd shed the power in this order in order to meet our interruptible demand. So it's maybe not total interruption, but partial interruption. So I don't know if that answers your question, but it's more on the integration of supply and demand, because the solutions really require understanding how you're buying the energy.
Yeah, okay, so I was just trying to understand the approach. So I understand the supply side dynamics of that. I was wondering if you were also coming at from the process side dynamics.
Not yet. I'd be interested in hearing more from you on that, if you maybe after.
So one of the things, if looking at, if I understood what you're asking about using more energy in part of the process and saving overall rather than splitting it by machines or assets, one of the tricks to this, if you will, is drawing the boundaries around what is a machine with the inputs and the outputs of it. Because, of course, even in Stewart's case, as he was saying, we look at a tissue machine, but there's zones and areas of the tissue machine where you have drying taking place, and you can do it in several different ways. And so those are always a balance, but that's the reason we're kind of looking at it overall, if that's kind of what you're talking about as well.
Okay.
I bet we will begin to tune the process, because dewatering before you dry the tissue, you might be using more energy in your dewatering process, or actually add components that would let you remove water before you have to dry it. And you could see the cost optimization balance, because you're going to get real-time cost information from your overconsumption out of these dashboards. So that's probably a wave 2 result as an output of using this as a tuning tool for energy cost optimization.
Okay. Manuel, did you want to speak to any of the issues of benchmarking and how you set the benchmarks in the beginning of the process? I think that was the first question that came through. And how maybe you, through continuous improvement, do you have a comment on that? Or
except continuous improvements, I'm sorry. Continuous improvements, it's obviously active, an active practice, right? It's how we dealt a lot with that in the organizational psychology is, by establishing breakthrough objectives, right? So from that perspective, right, we ask our team to think in something that is considered impossible, like 95% OE or 99% OE or 0 accidents in a very challenging operation with safety, right? So when you start putting that mentality across a breakthrough that is considered impossible, a lot of ideas start coming into play so people can align and start thinking of success. So that's what I would add about continuous improvement for that perspective, and that's sort of like the Honeywell model around that. So,
all right, thank you. Are there any other questions? One more up here, David. This probably is the last question because we're running on to the end of the time slot.
Hi, this is Rajesh from TCS. This is for Manuel. So in the context of your application, you mentioned about use of cloud for data collection. Now I wanted to understand what is the kind of volume and velocity and variability of data that you are handling, and are you dealing with any unstructured form of data in terms of videos or any other form of data which is not necessarily numerical? And what made you drive towards go for a cloud-based solution?
I have the expert here with me that can give you that answer perfectly well. So,
In terms of volume of data, I mean, it can be adjustable from that standpoint. So, I mean, during the cell testing, I mean, some tests will go at 1 hertz, some at 10 hertz, some at 100 hertz, some with 50 channels, some with 100 channels. So the volume, varies tremendously. Some of it can be analyzed in real time and then doesn't need to be kept necessarily, while a lot of others is mandatory to keep to dive into that over time to find trends. So in terms of an average of what is kept, it's in terms of gigabytes per day that is kept from that standpoint. Now, again, there's ways of handling that, of compressing it and things of that sort to keep the amount of data down. In terms of running into issues with it, there haven't been any issues of yet. I mean, the tools are good enough to be able to handle those mass amounts of data, and that's really not considered very much. There is video that takes place while the tests are running. That is also maintained from that standpoint, so it's not data, so to say, from that standpoint. So yeah, there's a variety of different types of data that is collected and all stored in the cloud. And again, the goal is to be able to do these comparisons and analyze across facilities, across countries, and to find trends that were just absolutely impossible to do before. So the goal is to absolutely keep all the raw data. I mean, and so that way you can go back and recalculate, you can make minor adjustments to do calculations, see what would my result have been if this was slightly different. So by keeping the raw data, not the calculated data, it gives you so much more flexibility when doing analysis and diving into it. So by no means do we want to summarize data or to throw data out that there could be any value in whatsoever, unless, again, we know right up front it's just for the real-time use, and other than that, that's it. But other than that, yeah, it's keeping all the raw stuff and volumes of it. But again, it's really not that much data for today's standards, so it hasn't been a problem.
All right, well, thank you very much, and I want to thank you all for attending, as well as I want to thank all of the speakers very much for putting all their effort into this particular session.